Okay, so this PreCalc 4.2 notes notebook, we're using one trig. We're doing example 3, and remember this is the actual day 2. I know on day 1 we kind of spread that out over a little bit because we have a lot of questions. But today we're letting theta be an acute angle such that the sine of theta is equal to 5/6. I rewrote that. I just can't stand that non-horizontal fraction bar. Evaluate the other 5 trig functions of theta. Now, keep in mind I know stuff. First of all, I know the sine already. That's done. And this is theta. I can find this missing side by using Pythagorean theorem. So I have a squared plus b squared equals c squared. And I already know 5, and I know c is 6, so I plop those in. So now I know that this is 36 minus 25, and that's 11. So a squared is equal to 11, and the square root of a and 11 is square root of 11. So this missing side's with the square root of 11. Okay. Now, with that said, I'm doing the trig functions. I'm not finding the angles. I haven't used an inverse yet, and I know you know those things. So let's just continue on with our cosine is adjacent over hypotenuse, so it's the square root of 11/6. The tangent is opposite over adjacent, which is 5 over the square root of 11, or I'm going to be going 5 to the square root of 11/11. Okay, and now I'm going to go to the races for, sine theta is the same as, if I take the inverse of it, it's the same as cosecant, and that's, remember, hypotenuse over opposite, and that's 6/5. And the cosine and the secant are related because they're inverses. So the secant is 1 over cosine, which is the adjacent over cosine is adjacent over hypotenuse, so the secant's a hypotenuse over adjacent. And so I've got this, so I got to get rid of the square root of 11, so I get 6 to the square root of 11/11. And now I got the cotangent theta, and I'm looking at that, and I've got this value, 5 to the square root of 11, so take the reciprocal. And remember, tangent sine over cosine, which is adjacent, opposite over adjacent, so cotangent's adjacent over opposite. Couple things about your calculators. The danger of evaluating trig functions with a calculator: you got operator error, fat fingeritis, but using the wrong mode. We talked about the mode, degrees versus radian. That's all in your mode key, and so you need to know the difference. But also, more so, you've got to be able to pay attention whether you're in degrees in the problem or in radians. So, using the wrong mode, degrees and radians, or how would you know if this is wrong? Well, here's the deal. If I evaluate sine 10 degrees, sine of 10 degrees is in the first quadrant. And I know stuff about sine and cosine. Sine and cosine are our x and y coordinates in that area. And so when I'm thinking about that, if I have this going on, and I'm in the first quadrant, okay, and I'm talking about the sine of something that's 10 degrees. Well, generally your x value is your cosine value, so that's going to be positive in the first quadrant, and your y value is your sine value. That is going to be positive, again, in the first quadrant. So when I'm looking at the sine of 10 here, and I'm thinking, sine of 10, and I get this value, this is communicating to me, screaming to me that my calculator is currently sitting in radians, because 10 radians is 1 time around, that's 6.28, and then 4, it's over here. Okay, but it's not only is it over here, but 10 radians, let's get 10 radians in there. And remember, 10 radians this is 6.28, and that's 1.5 more, and that's another 1.5 more, so that's 3.14 more, so that's 9.42 right here on the axis. And so 10 is right in here. So that is forcing my negative x, negative y, so that's why it's a negative 0.5440211. So you got to be aware of your calculator's mode, but also have a sense of what you're finding when you're finding it. Now make sure as you're going through, you look at this -1, okay? And now this is the tangent of 30, and that's the inverse of this. Now you got to be thinking, I have a relationship the tangent of 30 is used to help me find the cotangent of 30. So evaluating the cotangent of 30, I'm looking at the tangent of 30 reciprocal. So it's 1 over the tangent of 30. And that's what this does. This is the same as 1 over tangent of 30. So this is 1 over tangent of 30. Okay, I'm sorry. I'm writing with my mouse. I'm not very good with it. This is the inverse of tangent. So it's going to take a ratio and return, in the case of my calculator right here, is I'm in degrees. So it's returning an 88, and this is a degree value. Okay? And this one itself is a ratio. Okay? This is a ratio of cotangent of 30 degrees. This is an angle value, and that's what this does. Because of this, we're going to learn about something called arctan, arcsine, arccosine, and arctan because of this discrepancy with the -1. Okay. Now, using function shorthand that the calculator does not recognize, this error is less dangerous because it usually results in an error message. We'll often abbreviate powers of trig functions, writing, for example, sine third theta, cosine of the third theta, instead of more cumbersome sine theta raised to the third power minus cosine theta raised to the third power. Calculator does not recognize the shorthand notation and interprets it as a syntax error. So when we do this, especially when we're working with trig identities, this is just a shortcut notation. Your calculator, this is what it means inside your calculator. Now, one of the other issues that we have is not closing parentheses. This not closing parentheses is a big deal. So I need you to practice this. If you got the sine of 30, that should leave the 0.5. And then if you go the sine of 30 and then you add 2 to it, you get 0.52, which is the sine of 32 versus the sine of 30 plus a value of 2. So you have to pay attention to what you're doing when you're doing it with your calculators. Now, it is usually impossible to find an exact answer on a calculator when evaluating trig functions. Okay, so show why the following trig identities are true. And as I'm looking at them, I'm going to show them why they're true. So the cosecant theta is the same as hypotenuse over opposite. Okay, that's the cosecant of theta. And that's the same as 1 over sine of theta. So I've got the 1 over sine of theta, okay, which is opposite over hypotenuse. And according to the rules of fractions, this is flipped. So division by a fraction is the same as multiplication by its reciprocal. So we kept things the same, and that is the same here. So hypotenuse over opposite. Now here I've got tangent of theta equals sine theta over cosine theta. Well, the tangent of theta is opposite over adjacent, but the sine of theta is opposite over hypotenuse, and cosine of theta is adjacent over hypotenuse. Well, when I multiply these, because I multiply by the reciprocal, the opposite of adjacent, which is tangent, is equal to the opposite over hypotenuse times the hypotenuse over the opposite. So the hypotenuses are going to cancel, and my final is going to be opposite over adjacent. Now, remember, this is just a brief touch on what it's going to be like in Chapter 5. We're not going to be really using opposites, hypotenuses. We're going to be using sine, cosine, tangents, because we're going to know those values very well. This is a Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. And really what it's coming down to is a sine squared of theta is a over c, but since it's squared, it's a squared over c squared. Cosine squared theta is b over c, is b squared over c squared. Okay. Now, if that's going to equal 1, that same value is a squared plus b squared all over c squared. So I know a relationship that lets me do this is that a squared plus b squared is equal to c squared, because that's the Pythagorean theorem. So I can actually say that by substitution, that a squared plus b squared is actually equal to c squared. So I can actually clone this. Let's try this way, so I can get the whole deal. For whatever reason, that's not coming up. So we're gonna have to see Bloom try to write again. Okay. So by substitution, I know that that is the same as c squared over c squared, because, and that's going to equal 1, because Pythagorean theorem-wise, a squared is equal, a squared plus b squared is equal to c squared. Okay. Now, all triangles have 6 parts. When we find all three sides and all 3 angles, we are solving the right triangle. Okay, so a right triangle with a hypotenuse of 8 includes a 37-degree angle. Find the measures of the other angle and the lengths of the other 2 sides. I say the other angle because I don't have to. This is a typo, and I apologize for that. So finding the other angle is quite quick. It's the difference of 90 and 37, because in a right triangle, the 2 acute angles are 90 degrees. So 90 minus 37, this is a 53-degree angle. Okay. Now, to find A, I'm doing opposite over hypotenuse. I'm going to use sine. So I've got sine of 30 equals A over 8. So I multiply by 8, and I got 8 sine 37 is equal to A. And I said sine of 30 is actually sine of 37. I put this in my calculator. My calculator must be in degree mode, and it's 4.815 equal A. Now, finding B, I've got the cosine of B, or cosine of 37, is B adjacent over hypotenuse. And I'm setting up my ratio this way. This is my adjacent value of my hypotenuse is the same ratio as the cosine of 37, making sure your calculator is in degree. Multiplying by 8, it's 8 cosine of 37 equal B, and 6.389 is equal to B. So I have found my angle and my 2 sides. My last problem today, a real-world application involving indirect measurements, are frequent. We need to be able to find distances that we would rather not measure directly. Okay, so finding the height of a building from a point 340 feet away from the base of the Peachtree Center Plaza in Atlanta, Georgia, the angle of the elevation to the top of the building is 65 degrees. So we get angle of elevation 340 feet away. So really I'm looking for the height. This is an opposite over adjacent problem, so I'm going to be using tangent. The tangent of 65 is going to be equal to the height over 340. Well, I just multiply by 340. Tangent of 65 is equal to h. So you got to keep in mind the hard, difficult part of this is knowing what mode your calculator should be in. And when you're working with degrees, you're actually working with angles in degree mode in your calculator. So you got 729.132 as your height. Keep in mind, you've got to know your units when you're working with this. So you're going to find out that the Peachtree Center Plaza in Atlanta, Georgia is 729.132 feet tall. Okay, if you have any questions, make sure you ask them in class, and we'll see what we can do about clarifying those. Hopefully the notes went well and things are going swimmingly for you. This is our day 1 assignment and our day 2 assignment. So if you've got any questions, let me know and we'll get going on it. Make sure you're correcting online and handing in class, and good luck with things. And by the way, a little reminder, our test is next week.